Welcome back to Akbar Academy, the place where we don't just teach science, we bring it to life. I am Kaleem Akbar, teacher, author, and your guide through the invisible world that makes everything tick. Today's episode: we're unpacking matter. Seems simple, right? Solid, liquid, gas. But what if I told you most of what you think you know about matter is a bit of an illusion? To help me explore this, I'm once again joined by the minds who shaped physics as we know it, Sir Isaac Newton and Professor Albert Einstein. Gentlemen, welcome back.
A pleasure, Mr. Akbar. The world may appear solid and still, but beneath its surface lies astonishing motion. I must say, the particle nature of matter is something I suspected, but the full picture emerged long after my time.
Indeed. And as the brilliant man beside me might humbly agree, it all begins with motion. Even in what appears to be a perfectly still object, particles are dancing constantly.
Exactly. Like a wooden table, solid to us but on a particle level, it's mostly empty space between atoms, all vibrating with kinetic energy. Wild, right?
And this motion is not chaotic without cause. In solids, particles are held tightly in a fixed structure, but still they vibrate. Think of ice. Its molecules are locked in a lattice, yet they never stop moving.
And when you add energy, say by heating, it's like giving those particles a hall pass. Once they gain enough kinetic energy, they break free. At 0 degrees Celsius, ice becomes water. That change? A transformation in state, driven entirely by energy.
So, temperature is really just a measure of how energetic those particles are?
Exactly. Temperature measures the average kinetic energy of the particles. More heat means faster movement, less heat, slower particles, and at absolute zero, that's minus 273.15 degrees Celsius, particles would stop moving entirely. Though, we've never truly reached it.
The closest, I believe, is within a billionth of a degree above absolute zero. An impressive feat, even by your modern standards.
That just blows my mind. And this also connects to pressure, doesn't it? When we compress a gas, we're not squashing the particles. We're squeezing them into a smaller space.
Exactly so. The particles themselves remain unchanged, but you reduce the volume, and those particles collide more frequently. That's Boyle's law. If temperature remains constant, pressure and volume are inversely proportional.
Or in simpler terms, halve the volume, double the pressure. A useful principle, whether you're working with a gas syringe or a high-pressure steam engine.
And if we raise the temperature, those collisions become even more intense?
Absolutely. Higher temperature equals faster particles, which means more energetic and frequent collisions. It's why a pressure cooker works so well. It traps steam, raises pressure, and cooks food faster.
And that explains those warning labels on aerosol cans. Keep away from heat. Too much energy, too much pressure, and boom!
Quite. Matter in the gaseous state is far more sensitive to these changes, owing to the freedom of particle movement.
That brings me to one of my favorite real-life demonstrations of particle motion. Brownian motion.
Ah, yes. A pivotal experiment. Scientists watched tiny smoke particles under a microscope. They jittered randomly, not because they had energy themselves, but because invisible air molecules were constantly hitting them.
Indirect evidence, yet powerfully convincing. The kind of experimental detail I would have greatly valued in my time.
And those molecules, moving at around 500 meters per second, faster than the speed of sound, inside the air you're breathing right now.
It's a symphony of motion. Millions of collisions happening every second, unseen to the naked eye.
And all of that's happening, even in your coffee. Think about it. You've got liquid water in the cup, steam rising off it, and if you drop in ice, there's solid water too. All three states of matter, right there.
Each one governed by the energy of its particles. In solids, tight bonds. In liquids, more movement. In gases, total freedom.
It's not just academic knowledge, it's your everyday reality. Even your fridge relies on these principles. Compress, expand, absorb heat, repeat. That's thermodynamics at work.
So, in a way, we're all doing physics every day without even realizing it. cooking, breathing, running, even storing leftovers.
The unseen laws of matter and energy are always in effect.
And understanding them gives us the power to change the world. More efficient engines, smarter cooling systems, even solutions to climate change.
That's why it's so vital we keep teaching this, not just as theory, but as the foundation of how the universe really works. From the breath in your lungs to the vacuum of space, it's all particles all the time. So remember, dear listener, matter matters, because what looks still is always in motion. And here at Akbar Academy, we're not just about lessons, we're about opening eyes to the universe around us, because we are always Akbar Academy, a class above the rest.